Bismillahirrahmanirrahim. Honorable teacher and dear audience, Assalamu alaikum. This is Ruhul Amin before you. I'm really privileged to introduce myself in a place like this. Today, we are excited to present the fundamental of software development lifecycle. It's called SDLC. It's also called system development lifecycle. So let's do it. First, we introduce our team. Ruhul Amin is myself, Nasib Ajam, Torun Dotto, and Rokibuzzaman Rion. The content we'll talk about in this presentation: introduction of SDLC, planning phase, analysis phase, designing, development, maintenance, and summary. Introduction. What is SDLC stand for? SDLC stands for Software Development Lifecycle. As I mentioned, it's also called System Development Lifecycle. It's a process that gives a complete idea about development, designing, and maintenance of a software. Imagine you need a software. SDLC will ensure the total documentation in this way. Phases of SDLC. There are 5 phases of SDLC. First, we planning about the software. Then we analyze the whole thing. Then design, development, and maintenance. Planning. In this planning phase, we'll talk about analyze the requirement, feasibility study, project planning, system designing, prototype the design, and also estimate the costing, risk analysis, and the documentation. Whole process starts with planning. Analysis. After planning, we need to analyze the total prototype. We need to analyze the total system. What will be the model of the development? It could be waterfall, agile, it could be any other. So analyze section, we'll talk about system architecture, datagram, documentation, development environment, development strategy, etc., etc. As you can see the image, we can see the development page, analysis page in this particular analysis system. Now, I would like to request Nasib Ajam to present his phase.
Thank you, Ruhul Amin. Honorable teacher, thank you to give me this opportunity. In my slide, I describe my parts, which is design phase. The design phase are distributed in 2 parts. One is logical design and another is physical design. We need to design both physical and logical parts. And abstraction design usually by modeling. Second is logical design to abstract representation of data flow, input and output of the system. The description of the input, output, database, procedures, all in a format because of user requirements. Data flow diagram, ER diagram modeling are used also. My next slide is physical design. The technology specific details from which all programming and system construction can be accomplished. Second is physical design related to the actual input and output process of the system. Third one is the procedure of the working system by defining the design specification. The fourth one is it is concerned with user interface design, process design, and data design. The physical design consists of these following steps: specifying the input-output media, designing the database, and specifying backup procedures. Planning system implementation, test and implementation plan, specifying any hardware and software, updating cost, benefit, conversion data, etc. Now I would like to invite Rokibuzzaman Rion to continue our presentation.
Thank you, Nasif, for inviting me. So, welcome everyone to the implementation phase of the software development lifecycle. I'm Ruhul Rion and a member of this team presenting this implementation phase. This is the fourth phase of SDLC where we take all the planning and design work that we have done and turn it into a functional software system. It has three main parts: coding, testing, and debugging. On the next slide, we have the coding section. Please move on to the next slide. On the next slide, we have the coding section. The first step in the coding phase is to build the software according to the specifications and design documents that were created in the planning phase. Defining problem, planning the solution, and developing the code is the main criteria of this phase. This may involve updating code, integrating third-party libraries, modules, and testing the software to ensure it meets the required functionality and performance. Now let's move on to the next slide for testing section. Once the software has been built, the next step is to test it to ensure it is working correctly and meets the requirement. There are seven main steps. For testing. The first one is unit testing. Unit testing is a software testing method where individual components of a software are tested to verify that they function correctly. Second one is integration testing. Integration testing is a type of software testing that aims to verify the functionality, performance, and reliability of a system by combining its components. Then we have system testing. This is the third step. That actually represent that it is a type of software testing that verifies the functionality of a complete system, ensuring it meets its requirements. Then we have acceptance testing. This is the type of software testing that ensures a system that meets customer requirements, and this is the key part of the software development process. Also, we have the performance testing, security testing, usability testing also. Any issues that are found during testing that should be addressed and fixed before moving on to the next step. And the next step is the testing section. Once the software has been tested and any issues have been addressed, it is ready for debugging and deployment. Deployment involves installing the software on the target systems and making it available for use. This may involve configuring the software to work with the hardware and operating system, identify errors, implement changes, analyze the source code, as well as setting up any necessary security measures. After deployment, it is important to monitor the software to ensure it is functioning properly and to address any issues that may arise. This may involve collecting users' data, monitoring performance, and fixing any bugs or issues that are discovered. Finally, it is important to maintain the software over time by releasing updates and patches to fix bugs and add new features. This ensures that the software remains useful and relevant to the users. Thank you for joining me for this presentation on the implementation phase of the system development lifecycle, SDLC. I hope you have a better understanding of the steps involving in turning a software project from a concept into a functional system. Now, I would like to invite Mr. Torun Dotto to continue this session.
Thank you, Ruhul Amin, for giving me the opportunity. First, I'd like to introduce myself. This is Torun Dotto, Department of Computer Science, Green University of Bangladesh. So, we are talking about SDLC, and maintenance is the last phase of SDLC. Once the system is deployed and customers start using the developed system, there are three following activities occur. First, bug fixing. Bugs are reported because of some scenarios which are not tested at all. After that, upgrading the application to the newer version of the software, and enhancement, adding some new feature into the existing software. Now, next slide. Types of maintenance. In a software lifetime, type of maintenance may vary based on its nature. It may be just a routine maintenance task as some bug discovered by some user, or it may be a large event in itself based on maintenance size or nature. Following are some types of maintenance based on their characteristics. First, corrective maintenance. This include modification and updating done in order to correct or fix problems which are either discovered by user or concluded by user error reports. Then adaptive maintenance. This include modification or updating applied to keep the software product up to date and tuned to the ever-changing world of technology and business environment. And perfective maintenance. This include modification and update done in order to keep the software usable over a long period of time. Include new feature, new user requirement for refining the software and improve its reliability and performance. And finally, preventive maintenance. This include modification and updating to prevent future problem of the software. It aims to attend problem which are not significant at this moment but may cause serious issue in future. Next slide. Cost of the maintenance. So it is very important of the SDLC total life cycle cost. So first, in this graph, we can see that requirement cost 3%, designing cost 8%, implementation cost 7%, testing cost 15%, and the rest of the total cost, maintenance cost, is 67%. Reports suggest that the cost of maintenance is high. A study on estimating software maintenance found that the cost of maintenance is high as 67% of the cost of entire software process cycle. Next. Summary. The SDLC is a crucial process that helps organization to create successful software product. It includes all the necessary steps and phases of creating a reliable and secure software product. The SDLC ensures that all requirements are met and the product meet the user's expectation. So in this presentation, we talk about phase of SDLC. After that, we discuss about planning. Then we discuss about a different type of analysis of SDLC. And then we discuss about different type of design like physical, logical. Then we discuss about implementation, coding, testing. And finally, we discuss about maintenance. So that's all about this presentation. That's being me the end of our presentation. If you have any question, please ask me or email me. Thank you.